Good day, sir. I'm Cadet Briones. So today I will going to demonstrate the collision avoidance triangle to figure out what ship is a threat to us on the radar. So as we start, we have our own ship's data. Our own ship's course is 000 and our own ship's speed is 20 knots. The radar scale is set to 12 nautical miles and plotting is done in a 6-minute plot. So the target is the time is 1400s and it has a bearing of 45 degrees and a range of 11.5 nautical miles. So once you have that information, then we're gonna plot that position on our plotting sheet. So first is we're gonna find the 45 degrees. Next is we're gonna take our compass. Then we're gonna go to the 12 nautical mile scale and we're gonna measure the 11.5. So the first plot we're gonna label it R 1400s. Then now since we are doing a 6-minute plot at 1406, we're gonna take another range and bearing of the target ship, and that range is gonna be 9 nautical miles and bearing is gonna be 43 degrees. So now we're gonna go to the 43 degrees. Next is we're gonna take our compass to the 12-mile scale, measure 9 nautical miles. So the second plot we're gonna label it M and 1406. So now we have our own second mark. We're gonna label it M. Then we're gonna figure out the most important information of the target. So now is we're gonna find the CPA distance, CPA bearing, and then we calculate the CPA time. So for now, we're gonna draw a line down past our ship, and that's our relative motion line. That's our RML. Then once we are done with the RML, we're gonna find our CPA. So to find our CPA, we're gonna go to the 90 degrees angle and the closest point of approach. So that's the CPA. Then to find the distance of the CPA is gonna take our compass and measure the distance from our ship to the CPA point. And CPA distance is 1.4 nautical miles. Next is now we have a distance of the CPA. Now is we have to find the bearing, and we're gonna go from our ship out to the port of the CPA. So our ship 322. CPA bearing is 322. So now it's done. The next thing we're gonna do is we're gonna find the time of the CPA. So to find the time of the CPA is we're gonna go to the formula of time equals distance divided by speed over speed. So to measure the distance, we're gonna measure the m to the point of the CPA. So the distance, m to the point of the CPA, then connect it to the third nautical mile scale. We have 8.9. We have 8.9. TDS. TDS. 8.9. Then next is for speed, we're gonna use again the formula speed equals distance over time. So measure the distance from R to M. R to M. It's 2.5 nautical miles. 2.5 nautical miles. So next is we're gonna use my calculator. Then 2.5 so 6 minutes divided by 60 equals 1 equals 25 knots. 25 knots. We have 25 knots. So that's his RMS. Next is then the 8.9 divided by 25 then equals to 3.35 times 60 equals 21 minutes. Then since we get the distance from the M to CPA, we're gonna use the time from M, 1406. Then 1406, then add the 21 minutes. Minutes to get the actual time of the CPA. Then answer is 427. So 1427, so that is the time of the CPA. 1427, that is the time of the CPA. That's it. So now that we got the CPA distance, CPA bearing, and the CPA time, now we want to get the true course and true speed. So we are done finding the R and M. Now we're gonna find out where the E is. So to find the E, I'm gonna take our course, which is 0000, this. So next is we're gonna slide this over R. We're gonna slide this to R. Like that. Then we're gonna draw a line. That's it. So now that I had used my course, so now I have to use my speed. So my speed is 20 knots. So how far I'm gonna go in 6 minutes if I'm going 20 knots? So I'm gonna solve it by 20 times 6 divided by 60. So equals 2 miles. So 2 miles, then we go 2 miles, then we go to the 12-mile scale and get the 2 miles. So that's the 2 miles, and that mark is our E. Just label it E. That's it. So now we establish where the E is. So we're gonna solve the target through course and through speed. So we're gonna draw a line from E through M like this. Then we're gonna slide it to, and then we're gonna bring it back to the center so that we can read what's the course. So the course is 286. 286. So that's our course A. This is our course A. Then now we have the target rope course. We have to find the speed. To find the speed, just take your compass and then uh, measure from E to M and go to the 12-mile scale. So that is 2.1. The so our speed is 21 knots. I'm gonna write here 21 knots. Then that's it. So the line connecting E to M, it gives us the true course and true speed of the target. This A to M, it gives us the true course and true speed of the target. So we already realized that this vessel is on our starboard bow. He is the stand-on vessel and we are the giveaway vessel. So we have to maneuver in order to avoid this vessel. So let's say for example, the captain may say that he don't want any vessels to come within the 2 miles radius of our ship, right here. Now, in order to figure how much of a course change, we have to take this. We have to take this relative motion line right here. We're gonna move it outside the circle because its current situation, it's gonna be 1.4 nautical miles. So we want to make it a 2 miles radius outside of our perimeter zone. So now when we do that, we have two ways of establishing this. We know that the vessel is traveling down relative motion line, and when the vessel is traveling 3 miles and it touches the 3-mile range ring that I have in my radar, that's what we are going to change course, and we're gonna call it MX. So right here I already put the MX here, or the point of execution. That's what I'm going to change course. So that will become our pivot point. Now what we're gonna do is we're gonna take this relative motion line and we're gonna pivot it above the MX like this. We're gonna label it NRML, or new relative motion line. And now we have our new relative motion line. Next is we're going to take this line at the same angle and take back the relative motion to M. We're gonna take this back to M, this, and draw a line. Then this is ARML, or advanced relative motion line. So now it's done. We now have to go back to true motion vector, which is represented from E to R. True motion vector can never leave E, so we're going to change course to the starboard. So we're going to take this line represented by ER, which is our course and true speed, and we're going to pivot it to the right because we're literally going to change course to the right. So to make this accurate, we're gonna use our compass, and we're going to take the distance from E to R, and we just make an arc. This E to R, wala na. E to R, then we just make an arc like this. That's all. Now it's done. Now we're done making an arc. Now we're going to redraw this line, and we just pivoted it above E, because right like this here. Oh. This is our new course. This is our new course. Now we have our new course, and what we're gonna do is we take that angle and just slide it back to the center of the plotting sheet like this. Then H 43 degree 43 degrees. So now we get the new course. Our new course is 43 degrees. True. Now we're gonna find, I think that's it. So that's our new course, 43 degrees too. So that's all for the video. Thank you for watching. God bless and stay safe.